So hello guys, today we are going to discuss about the Prim's algorithm, Kruskals algorithm and Dijkstra's algorithm. So what's Prim's algorithm? It calculates the minimum spanning tree in a connected and weighted graph starting from the selected vertex. To understand the algorithm, it's important to remember that a spanning tree of a connected graph is a subset of edges that forms a tree connecting all vertices, while a minimum spanning tree is a spanning tree whose sum of weights is as small as possible. Prim's algorithm uses the greedy approach, therefore it makes the decision of what to do the next by selecting the best local option without regard to the global structure. To get an example for this, we have a node B, and from that node B we have a nearest thing is B. Then the possible routes to choose from the B is C and D, but we need to choose the nearest one. So we consider B to C, and like that we have two options, D to B, but we select the nearest option. Thus this gives the Prim's algorithm. Next, to tell about the Kruskals algorithm. Kruskals algorithm is a way to find the minimum spanning tree of a graph. We have the key points as sort edges. List all the edges in a graph and sort them by weight. Pick edges. Start picking the small edge and add it to the MST if it doesn't create a cycle, basically a loop. Now repeat. Continue the picking edges until you've added enough edges to connect all vertices. And we have n minus 1 edges for n vertices. And result, the edges you've picked from the minimum spanning tree. The algorithm ensures you connect all the points with least total edge weight. To get it, we have an example as say here. From the first step to the sixth step, we are planning to get a least minimum spanning tree. From that, this is the result we get. Now Dijkstra's algorithm. Dijkstra's algorithm is also known as the shortest path algorithm. It is an algorithm used to find the shortest path between nodes of the graph. The algorithm creates a tree of the shortest paths from the starting source vertex from all other points in the graph. It differs from the minimum spanning tree as the shortest distance between the vertices may not be included in all the vertices of the graph. The algorithm works by building a set of nodes that have a minimum distance from the source. Here, the Dijkstra's algorithm uses a greedy approach to solve the problem and find the best solution. To cover it with steps, all nodes should be marked as unvisited. All the nodes must be initiated with an infinite distance. The starting node must be initialized with 0. Mark starting node as the current node. From the current node, analyze all of its neighbors that are not visited yet and compute their distances by adding the weight of the edge, which establishes the connection between the current node and the neighbor node to the current distance of the current node. Now, compare the recently computed distance with the distance allocated to the neighbor node and treat it as the current distance of the neighboring node. After that, the surrounding neighbors of the current node which has not been visited are considered and the current nodes are marked as visited. When the ending node is marked as visited, then the algorithm has done its job. Otherwise, pick the unvisited node which has been allocated the minimum distance and treat it as the new current node. After that, start again from the step 4. Now we have the programs regarding them. We import the heap and create a minimum step to store the wedges in Prim's algorithm. We create a cost and vertex, set the track to visited vertex, total cost of the MST, and listing the stored of edges. Now we use a while loop to get the edges with the smallest cost, and as continue if we have already visited the node. Now adding the minimum cost tree and the cost of the total. If the total cost is not 0, it's not the starting vertex. Now adding the edges and exploring its neighbors along with tracking the previous vertex. Now we will return it. So here we have an example of the vertexes given A, B, C, D, and running the program algorithm. Thus we give the output as total cost as 4 and edges A, B and B, C and C, D from the above graph. Now Kruskals. We have defined the classes, different classes for that. First edge of a vertex, second edge, and weight of the class. Now we initialize the parent pointers, and with another function we find the root of the vertex. With union, we of two union of the sets, we add two vertex 1 and vertex 2. With another function, we initialize the result for the minimum spanning tree and create a disjoint set to the image managed components as disjoint, for variable for loop for initializing the each vertex and sort edges. If the vertices of the edge are in different sets, we use the for loop. Now return the edges in the minimum spanning tree. As we have an example for that, list of all edges and vertices. So we calculate the minimum spanning tree with Kruskals algorithm, and the for loop to print it. For loop to have a results, then the total results. So as you can see, we have a output here. Kruskals algorithm, from vertex 2 to vertex 1 the weight is 2, from vertex 3 to vertex 2 the weight is 3, and 0 to 3 is the weight is 3, and 2 to 4 it is 7. Now we get the total weight as the 15, as it is the minimum. Now we discuss about the Dijkstra's algorithm. So we imported the class of Dijkstra and imported the packages, so that we initialize a minimum value and we use for loop to return the minimum index, the for vertex in range to return the minimum index. Now we define another solution, print solution, the shortest distance from the source. We initialize distances, shortest path set, and distance from the source to itself as distance and source equal to 0. As we have talked that each first vertex is 0 and other vertexes are infinite. Then mark the vertex as processed, then updating with the for loop. Main code to run the algorithm, as we have an example for this. See, this is the to find the shortest from all the node, the program regarding it. We have the graph given, and from the starting from the source node we get the output as the shortest distance from the source to node 0 to node 1 to node 2 to node 3. Thus we completed it with the shortest distance. Thank you.